Hello and welcome to this Vectors Inc. video tutorial series on Pix4D Mapper. My name is Mike Kasman. I am the Sales and Support and Part 107 pilot in the Albuquerque office of the Vectors Inc. business. So today I wanted to start it off easy and talk about how to set up a new project in Pix4D Mapper. It's fairly straightforward, so let's just jump right in. The first thing that you're going to do, of course, is open up your software for Pix4D Mapper here, and you'll be greeted with this splash screen, which may show recent projects, your ability to open and make a new project right here. So we're going to hit New Project, and we've got to create a name for this particular one, which I believe we are just going to call, video demo. And we're going to store it here in this particular directory. That's customizable. You can browse and put it wherever you want if you have secondary storage or online drives or what have you. I would caution you that if it is not saved locally, you may increase your processing time due to the fact that it needs to download from an online source if you're using a cloud or something like that. You can set this as your default project location, and our project type is going to be a new project versus merging existing projects, which we'll get into later. That's a bit more advanced. So we've got our project named here. We're going to hit next, and now we just need to add images to this project in order for it to get started. Note that you have this red X up here which says we need at least 3 JPEG or TIFF, 3 images to get started. So we're going to add images to our project which we captured earlier. The drone that you use is not particular. It does not matter. And we'll get into perhaps some of the details about capturing with a drone and what you can do to ensure the best success later on in the series. But for now, we're just going to add images, and it asks us, okay, where are they located? So for us, we put them in a folder called Video Demo Images here. So I'm going to open this up, and you can see here they are. And I'm just going to do a drag and select all of these. I'm going to open them here. All right, so now we've got a green check which says enough are selected. Press next to proceed. We've got 17 total, their locations and their physical names here. Okay, so we just hit next to continue on to the next screen. Next, it asks you about the image properties. By default, all drones collect and capture in WGS84. Okay, so your image geolocation is coming from the WGS84, okay, and the EGM96 geoid. That's for your elevations there. All right, you can go in and edit this. I would caution you to make sure that you know exactly what you're doing before you get in here and monkey with these particular image geolocation, okay? Later on, you can set your project export, the coordinate system for what you want to export out, but all drones capture in WGS84. All right. Geolocation and orientation were found in 17 out of 17 images. Those were pulled from the EXIF, okay? And we'll show you the EXIF data in another video later down, but that's how it knows where to roughly place these images. And our geolocation accuracy is going to be custom versus standard or low. Again, details on why these things are important will come at a later time. So the selected camera model is also pulled from the EXIF data. So this particular image set was flown and captured with a NAFI, which is part of the Parrot series. And here you can see the images, their lat, long, height, horizontal accuracy, vertical accuracy, the omega phi and kappa, which is the orientation of the camera as it was taken. All right, all of that looks good. We don't need to change anything here. You don't want to get in here and adjust these because these were raw data inputs when the image was taken. One thing to note here is the ANAFI is not a production quality drone right out of the box. You would need to add ground control points and a number of other additional quality control elements to your flight. And as part of your flight planning, if you intended to use a drone like this for production quality. Otherwise, the geolocation here is relative unto itself, aka your positional accuracy. While this says 0.9 meters, it could be 1 to 2 meters, maybe even 3 meters relative to itself. It is not directly tied in. Okay, think of it as the L1 GPS level of accuracy, uncorrected. All right, so we hit next to bring these in. Here is where it's going to ask you, okay, what sort of output coordinate system would you like to do here? We, by default, get selected this one based on what the images came in as, but you can change it right here. All right, our units are in meters or feet. One thing with Pix4D is that you only get meters and imperial feet, not survey feet. Okay, right? A survey foot is 12 inches divided by 10, whereas the imperial is the straight up 12 inches. Okay. You can choose arbitrary coordinate system, you can do auto-detected, or you can put it into a known coordinate system here. Okay. So for example, if I go ahead and click that, it gives me a search box, and I can just go in here and type in New Mexico. You see how it's automatically populating things here? So you have your NAD 83, New Mexico Central, East, and West. Remember, New Mexico is divided vertically into 3 zones. You have your NAD 83 HARN, High Accuracy Reference Network, for the vertical here, Central, East, West. And if we scroll down a little bit, you've got your NAD 83 2011 epoch for Central, East, West. The NSRS 2007 epoch here. Then you have your NAD 83 State Plane, New Mexico Central versus East versus West here. So you would likely want this to come down into the state plane grid here. So I'm going to put that as our choice. You can see state plane New Mexico Central, FIPS 3002. FIPS is a reference system for the coordinates, and still in the EGM 96 geoid. Okay, you can click advanced here and pull from a PRJ, from a list, or from the EPSG coordinate system numbers. Here's where you can adjust your vertical, and this is a video topic entirely unto itself, so I'm going to just leave it as EGM 96 here, and we're going to hit next. Once this information has been saved, you get a choice of processing options. What sort of output are you looking for? Your standard are these 3: a 3D map, 3D model, or agricultural multispectral. The camera that we use with our drone is an RGB camera, so we're not able to do multispectral, it just collects in red, green, and blue. Then you have rapid production, and then you have advanced here. Okay, so rapid means I just need to produce a quick, let's say, orthomosaic or something of that standard there. 3D map, 3D model, or one of these ag things. For our purposes, because we don't have a lot of images, we're just going to do a 3D map. Okay, by clicking on that template there, you can see some extra information about your choice here: nadir flight and oblique flight, meaning orthometrically pictures and pictures taken slightly obliquely. The output quality and reliability is high. The processing speed is somewhat slow. And then some demonstrations of what you're going to be able to generate with this template, which is a 3D mesh, a point cloud, for example, or the mosaic and DSM. All right, that looks good. Let's go ahead and run with this. We're going to hit finish, and you see this box here which says start processing now. I'm going to deselect that and hit finish. Okay, so here's a property that I flew a couple days ago in the Albuquerque area, and what you start off with is just this general map of where the images were geolocated. You might remember that from when we imported the images on that screen. And then down here at the bottom is your processing box, okay? And in the bottom right, you can see you have your WGS84 to NAD83 horn, State Plane, New Mexico Central. Great. Now this is in meters, and in terms of using this program, I would recommend doing your measurements and bringing things in meters, and then you can convert them afterwards. It's a little bit nicer than trying to do the imperial to survey foot difference. Okay, so we're going to pause right there, and we'll pick this up in the next video in terms of what to do next. So thank you very much for watching, and please stay tuned for the next video.